Percentages will frequently be used in our study of statistics. Let's review some calculations involving percents. So in our first example, we want to convert 0.629 to a percent. So to change a decimal to a percent, we can multiply by 100% to get 62.9%. Now a shortcut to this is using the decimal shift method, 0.629, and we move the decimal 2 places to the right to get 62.9%. That's our shortcut. Okay, number 2. We want to convert 33.5% to an equivalent decimal. Okay, so 33.5%, and now we divide by 100% to get 0.335. But again, we can use the shortcut decimal shift method, 33.5%, shifting the decimal this time now to the left 1, 2 to get 0.335. In our third percent problem, we want to convert a fraction and our fraction is 3/10 to an equivalent percentage. Now, there are 2 ways to do this. The first way is to recognize that percent means per 100. So if we could get our fraction in the form of something over 100, then we would be able to easily convert that to a percent. So in this case, with 3/10, that wouldn't be too difficult. We can multiply the top and bottom by 10, which is the same as multiplying by 1, and we end up with 30 over 100. So per 100, 30 per 100 is 30%. But it's not always easy to convert the denominator to 100. Another way would just be to take 3 divided by 10, which is what a fraction represents. 3 divided by 10 will give us 0.3, and then we can use our decimal shift method, 1, 2, and write that as 30%. Or we can take our 0.3 times 100%, the other method, to get our 30%. Okay. Number 4. What is 9% of 660? So one thing is helpful to know, that this word of indicates multiplication. Let me mark that. So with that in mind, we would say that this is basically the equal sign in an equation. So we're asking what equals 9% of 660. So 9% of 660 can be written as a decimal, 0.09, remember our decimal shift, 1, 2, times 660, and here we get 59 0.4. Now, in statistics, it'll often be the case that we're talking about maybe numbers of responses on a survey or numbers of babies born in a hospital, something like that. So we would tend to want to round this last number. I'm going to leave it as it is now, but because this was just a general question and not specific. But keep in mind that we often need to think of the context of the problem and do some rounding. Okay. Now let's look at a problem similar to one like we might encounter in statistics. A survey of 846 students was conducted. Approximately 35% of the students indicated that they often have difficulty finding a parking place on campus. How many students does this percentage represent? So the question is, what is 35% of 846? So we've seen that before. Now that we can understand what they're asking, this is back to a previous question, like number 4, the one we just worked. So we said we could change this to a decimal, 35%, move the decimal 2 places to the left in our decimal shift method. 0.35 of means multiply 846, and that comes out to be 296.1. Now remember what I said about rounding. It doesn't make sense to report 200, sorry, I wrote this wrong. It's 296.1. Trying to think and talk and write at the same time. Okay. 296.1. But that doesn't make sense. 296.1 students. So we would say, using our rounding, approximately 296 students. Or 296 students. Okay, so that's what we found. All right. Another question similar to this that we might encounter. Using the same survey of 846 students, 381 said they'd get more use out of the library if the hours were extended to 10 p.m. on weeknights. So now they're asking, what percentage of students does this represent? So they're saying 381 is what percent of 846? That's the question. All right, so 381 is what percent of 846? So we divide to get 0.45035. Actually, I'm stopping there. The decimals continue. And so now we would want to convert this to a percent. So 0.45035. We can do the times 100 method and get, I'm going to say, approximately 45%. Say I want rounded to the whole percent. We could also use the decimal shift method and go 2 decimal places to the right.